Continuing our work on quadratics, this section we're going to be looking at the properties of quadratic functions in standard form, as well as seeing what standard form is and how to get there from vertex form, which we've been looking at recently. So our two forms for quadratic functions, we have vertex form, which is what we've been working with, a times x minus h squared plus k, and we have standard form, which you have seen before, y equals ax squared plus bx plus c. That might bring back memories of the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We'll get there later on in the chapter. One of the big things that we're going to do is we're going to change from vertex form to standard form. We won't go backwards yet. Again, that'll be later on in the chapter. Going from vertex form to standard form is fairly easy. All we need to do is expand the squared. So, to expand the squared, first of all, we deal with the exponent. This is not x squared minus h squared. You cannot do it that way. Don't be that guy. You need to expand it. X minus h squared is x minus h times x minus h, which we can then distribute. X times x is x squared, minus hx, minus another hx is minus 2hx, negative h and negative h is plus h squared. Then we can distribute the a through, and that would be standard form. It doesn't look quite like this without numbers to combine. It looks really ugly. But one thing to notice here is ax squared, a. This is the same a in both equations. So everything we saw in vertex form with that a is the same as true in standard form. Bx, well, what's times x? Negative 2ah. So b equals negative 2ah. Is that super important as it is? No. But if we wanted to figure out what h equals, we could divide by negative 2a. H equals b divided by negative 2a. We'll see that on the next slide. And then c is the constants without any x's. It's just ah squared plus k. And again, we'll actually see that on the next slide too. So let's throw some numbers in here. Y equals 2, x minus 3 squared minus 1. First thing we need to do is deal with this x minus 3 squared. Again, not x squared minus 3 squared. X minus 3 times x minus 3, which when we distribute, we'll have x times x is x squared. We'll have a negative 3x, another negative 3x, gives us negative 6x, and then negative 3 times negative 3 equals positive 9. From here, we can distribute the 2 through, so we get 2x squared minus 12x plus 18 minus 1, and then just combine the plus 18 minus 1, gives us plus 17. This would be our equation in standard form. So let's do another one. And by let's, I mean try one. So we have y equals 3 times x minus 1 squared plus 2. See if you can do that. And don't be the guy that goes x squared minus 1 squared. Go ahead, pause your video and push play once you think you have it. So you think you got it? Let's see. First thing we need to do, we need to expand this, the x minus 1. Then we can multiply those together to get x squared minus 2x plus 1. Distribute the 3 through, and then combine the 3 plus 2 to get us y equals 3x squared minus 6x plus 5. Is that what you got? If yes, awesome. If no, where did you go wrong up in your steps? So we have our two forms for quadratics. We're going to look at some properties of our quadratic functions. And we're going to look at them for each of the forms, because sometimes we'll be working with standard form, sometimes we'll be working with the vertex form. It's nice to see where these things come from each of them. The first thing we're going to look at is what's called the axis of symmetry. We noticed that quadratics are symmetric, means that over here is the same as over here. In fact, if we spun it, it would spin right onto itself, which means that there's a line that goes right down the center of it, where it's a mirror image of itself. And so we could spin it right around the line. This line is called the axis of symmetry. Notice it goes through the center here. What's the center of our equation in vertex form? Well, that center would be h. It's a vertical line, so the equation for it is x equals h. Over in standard form, it's still going to be x equals h, but we don't have h. If you remember from the previous slide, we mentioned h equals negative b over 2a. So here, x equals negative b over 2a. I know that's kind of an obnoxious formula to be remembering, but it's really the only one, and it's going to show up over and over and over again in all of the formulas that we're going to work with. So we have h, negative b over 2a. We saw h in the past couple days in vertex form. That's the x part of our vertex. We look down there, it's like, that's our vertex right there. It goes right through the vertex, which should make sense. So let's look at what the vertex is. The vertex is h comma k. We saw that in the past few days. Well, so in standard form, that means the vertex is negative b over 2a comma something. How do we get this something? How do we get the y value for this x value? How do you get the y value for any x value? Plug it in. That's all you have to do. Just plug it into the equation. Right now, that would be ugly. But when it's a number, it's really not that bad, and we'll see that in a minute. So how does this formula look? Well, when you plug it into the equation, you just get f of negative b over 2a. This literally means we plug this into this equation. So that's our vertex. It doesn't look anywhere near as pretty as vertex form vertex, but that's what it is. Next thing we're looking at, does it open up or down? We saw this yesterday with vertex form. Is A positive or negative? If it's positive, it opens up. It's a happy parabola. If it's negative, it opens down as a sad parabola. The A is the same in standard form, so the exact same rule applies. If the x squared is positive, it opens up. If it's negative, it opens down. Now, some people wonder, well, it could be positive or negative. What if a equals 0? If a equals 0, you don't have a quadratic, so it doesn't open up or down. In vertex form, you'd have a horizontal line, because you'd have y equals k. In standard form, you'd have a line bx plus c. It doesn't open up or down. The y-intercept is another thing that we like to look at when we're graphing. Most of the time, we were looking at vertex form and then standard form. The y-intercept, it's actually easier to look at standard form first, and that's usually when we care about the y-intercept. So the y-intercept is when x equals 0. When x equals 0, x squared is 0 times a is 0 plus b times 0 is 0, and so you're left with just c. So the y-intercept is just 0 comma c. Over in vertex form, if we really cared what the y-intercept is, we'd plug in 0, minus h is negative h, squared is positive h squared, times a plus k. We get 0 comma ah squared plus k. If we remember back to that other slide, c equals ah squared plus k. What is the maximum or minimum? Every quadratic has exactly one maximum or one minimum. it happens at the vertex. If the quadratic is, hold on, I'm grabbing a pen. If the quadratic opens up and it's happy, it has a minimum. If the quadratic opens down, it's sad, it has a maximum. Regardless of whether it's a minimum or a maximum, it happens at the vertex. So the minimum or maximum is always going to be y equals the vertex, the y part of the vertex. So here it's just y equals k. And in standard form, it's y equals, well, the y part of the vertex, which, again, is a bit ugly, but it is what it is. And we'll keep these here for just a minute. But first, let's talk about domain. Domain, what can you plug in for x? Well, it doesn't matter what form you're looking at. It's still the same equation. What can you plug in for x? It's going to be the same for both. You can plug in anything for x. Well, how do we say anything? All real numbers. And then the range. The range is what can y equal? Well, y can't equal all real numbers because we're either going to have a minimum or we're going to have a maximum. If we have a minimum, y is going to be greater than or equal to this minimum value, the y part of the vertex. If we have a maximum, y is going to be less than or equal to this part of the vertex. So y is greater than or equal to k if it opens up, less than or equal to k if it opens down. In standard form, it's y is greater than or equal to the y part of the vertex if it opens up, less than or equal to the y part of the vertex if it opens down. Again, not pretty, but by this point, you'd have a number. Find a number up here, plug it in, find a number up here, and then the number just kind of carries through. So those are some properties of our quadratics, and we're going to use those to help us graph in standard form. We're not going to talk about graphing in vertex form. We've already done that. We're going to graph in standard form. And so to do that, we're going to make a table, just like we started out with vertex form. Before we looked at translations, we made a table. But in addition to making a table, we're also going to use the symmetry that comes along with a quadratic. So let's start with an equation. F of x equals negative 2x squared plus 8x plus 5. So we get a table. We can plug our equation into the table. And we need to start with a value. We're not going to use negative 2, negative 1, 0, 1, and 2. That was great for yesterday because the problems were set up for that to work. In typical cases, that might not get you there. What we really want is we want our vertex and 2 points on each side of that vertex. So in the centerpiece, we want our vertex. Well, our vertex is negative b over 2a. B is 8. A is negative 2, so we can plug those in. 2 times negative 2 is negative 4. And we have 8 over negative 4 is negative 2, but we have a negative here, so this all simplifies to positive 2. It's way nicer than negative b over 2a. It's just 2. Now we can plug that in to the equation to find the y part of the vertex. So when we do it, we have negative 2 times 2 squared plus 8 times 2 plus 5. Simplify. 2 squared is 4. 8 times 2 is 16. And then negative 2 times 4 is negative 8. Negative 8 plus 16 plus 5 is 13. And so we can put 13 into our table. So we have the vertex. Now we just need 2 points on either side. You can really pick the points that you want. You could plug in 1.5. I wouldn't recommend that. I would plug in the point on either side. Plug in 1 and 3, 0 and 4, just because those are the easier points to deal with. If you get too far away from the vertex, your graph is going to be huge. And plugging in things like 1.5, well, you don't want to plug 1.5 into here. I can pretty much guarantee that. So let's just plug in 1 and 3, and then 0 and 4. 1 and 3 should get us the same answer because of that symmetry. Same thing with 0 and 4. It should get us that same answer. So let's plug in 1 and 3 into our equations. 1 squared is 1 times negative 2 is negative 2. 8 times 1 is 8 plus 5. 3 squared is 9 times negative 2 is 18. Negative 18 plus 8 times 3 is 24 plus 5. And then we can simplify that. Negative 2 plus 8 plus 5 is 11. Negative 18 plus 24 is 6 plus 5 is 11. Notice that symmetry. You only really have to find one of these. If you found your vertex correctly, you find 1, I'd go with 1, and then 0. The others will mirror it perfectly. And so it saves you almost half the work. So we can plug those into the table. Now we can plug in 0 and 4. Well, 0 is easy. This is going to be 0. This is going to be 0. It's going to leave us with plus 5. 4, we have 4 squared is 16. Times negative 2 is negative 32. 8 times 4 is 32. Negative 32 plus 32 is 0. Plus 5. We get 5 for each of these. So we can put those into the table. Now to graph these, we just need an appropriate size graph. So we need to include 13. We need to get down to 5. I would include the x-axis as well. It's always nice to include your axes on a graph unless you are in some very, very large numbers. If our points were 200, 180, and 150, yeah, maybe the axis is too far away to really graph decently, but these are still pretty close. So we have our axis, we can plot our points, and then we can draw our graph. All right, and we get a quadratic, just the same as we had when we had a vertex form quadratic. So let's try another one. I'm going to make a table. We're going to use the symmetry, but this time you're going to try it first. So the equation we have, h of x equals 2x minus 1 plus x squared. Notice it's a little bit out of order. So go ahead, find the vertex, make a table, and graph it. Pause the video and play it again once you have finished with your graph. All right, how'd that one go? I think that one's a little bit easier than the first one that we did all together. So let's see what happens though. Get our table. Let's plug our equation into our table. And then we need to find the vertex. It's negative b over 2a, so we plug in b is 2, a is 1, which is just negative 2 over 2, which is just negative 1. Plug that into the equation. When we simplify this, remember negative 1 squared is positive 1. Then minus 2 minus 1 simplifies to negative 2. Put that into our table. And then get a few points from either side. I'd go negative 2 and 0, and then negative 3 and 1. The first time we plugged in, these points were easier. In this case, I'd say these points are easier, just because 0 and 1 are the easiest things to plug into any equation, pretty much. But let's plug them in. Negative 2 and 0. We get those. This one is obviously going to be 0 minus 1. Here we have positive 4 minus 4 minus 1. And each of them comes out to be negative 1. That symmetry is wonderful. Plug in negative 3 and 1. Again, I would be doing these calculations down here with 1. But if you really want to, You can do them with -3 as well. Just make sure that when you square that, you get a +9. And then you simplify to get it equals 2. Put 2 into our table. We need an appropriate size graph. Plot our points. And then draw the quadratic. And remember, when you're drawing your quadratic, make sure you're drawing it in a parabolic fashion. We want this bottom to be curved. We don't want angles. You shouldn't have a sharp point. Try and curve it as best as you can. So how'd you do on this one? Did you graph it right? Is your vertex at -1, -2? If yes, fantastic. You're ready to start class. If not, go back, see where you made a mistake. So this is the end of the topic. Be ready for a small group activity at the beginning of class. Then you'll have time to be working and practicing and making sure you get all of your questions answered. See you then.